The last time humanity stepped foot on the moon was on December 14, 1972. As part of Apollo 17, the sixth and final Apollo moon landing mission, Commander Eugene Cernan and Lunar Module pilot Harrison H. Jack Schmitt flew to Taurus Littrow Valley on the eastern rim of Mare Serenitatis. More than 50 years later, humanity finally has plans to return. In just 2 years, NASA is set to embark on a historic mission to return to the moon. From 1969 to 1972, NASA flew 6 missions to the moon. From Apollo 11 to Apollo 17, a total of 12 astronauts had the honor of walking on the moon's surface. Sadly, the Apollo program concluded in 1972, and NASA shifted its focus to the Space Shuttle program, which successfully orbited around Earth for over 30 years. However, the desire to return to the moon never waned. In 2004, the Bush administration launched the Constellation program with the goal of revitalizing America's space legacy and returning to the moon by 2020. Unfortunately, a 2009 report by the Augustine Committee exposed a harsh reality. The Constellation program was severely underfunded, and the planned 2020 moon landing was not going to happen. As a result, the Obama administration signed the NASA Authorization Act, which mainly called for 3 things: the dismantlement of the Constellation program, the development of the Space Launch System, or SLS, and NASA's continued refinement of the Orion crew capsule for future space missions beyond low Earth orbit. Then, in December 2017, the Trump administration introduced Space Policy Directive 1, calling for a US-led coalition of international and private partnerships to return humans to the moon by 2025. Unlike previous visits, the goal was to establish a permanent presence and set the stage for expeditions to Mars and beyond. On May 14, 2019, the program was named Artemis, in honor of the ancient Greek moon goddess and counterpart to Apollo. A year later, Administrator Jim Bridenstine unveiled the Artemis Accords, a series of agreements with collaborating nations outlining protocols for the peaceful and orderly exploration of the moon. As of January 2024, 34 nations have signed the Artemis Accords, becoming a truly global enterprise, uniting nations in the pursuit of returning people to the moon. The Artemis program will span 11 missions built around 4 foundational pillars: the Space Launch System, the Orion Spacecraft, the Lunar Gateway Station, and the Human Landing System, or HLS. In short, the Space Launch System will serve as the heavy-lift rocket that will carry the astronauts, Orion capsule, and other cargo beyond Earth's orbit. The Orion capsule, a partially reusable spacecraft, will transport the astronauts to and from lunar orbit. The Gateway will be a small, multi-purpose space station orbiting the moon, providing essential support for lunar surface missions and serving as a staging point for further deep space exploration. And the Human Landing System will then ferry astronauts from the Lunar Gateway space station to the moon's surface and back. Together, they pave the way for humanity's celestial rendezvous with the moon and beyond. This is Science with Lou, and today we'll go over the Artemis program missions and how these 4 components fit into the equation. Artemis 1, NASA's first major lunar spaceflight mission since the conclusion of the Apollo program 5 decades earlier, served as an uncrewed integrated flight test of the Orion Spacecraft and Space Launch System (SLS) rocket in preparation for subsequent Artemis missions. On November 16, 2022, at 1:47 p.m. Eastern Standard Time, Artemis 1 launched from Launch Complex 39B at the Kennedy Space Center, Cape Canaveral, Florida, using the Block 1 variant of the Space Launch System. The Block 1 vehicle consists of a core stage, two 5-segment solid rocket boosters, and an upper stage. The core stage, crafted by Boeing, measures 65 meters in length and 8.4 meters in diameter, housing a vast liquid hydrogen tank with a capacity of 2 million liters and a liquid oxygen tank with a capacity of 742,000 liters. Additionally, the rocket is powered by 4 Aerojet Rocketdyne RS-25 engines, generating a commanding sea-level thrust of 7.4 meganewtons to propel the spacecraft into space. The SLS core stage is aided by 2 towering 5-stage solid rocket boosters provided by Northrop Grumman. Both boosters stand at 54 meters high, 3.7 meters wide, and have a combined thrust of 32 meganewtons, generating over 80% of the SLS's launch thrust. Just 2 minutes and 12 seconds after the takeoff, the solid rocket boosters disengaged from the spacecraft, setting the stage for the next milestones. The Interim Cryogenic Propulsion Stage, created by the United Launch Alliance, is mounted on top of the core stage. It stands at 13.7 meters long, 5 meters in diameter, and carries a 110 kilonewton Aerojet Rocketdyne RL-10 engine, as well as liquid hydrogen and oxygen tanks. At 5 minutes and 51 seconds after the main engine cut off, the core stage separated, marking another crucial phase of the mission, executing the precise translunar injection burn that propels Orion from Earth towards the Moon. The Orion spacecraft was designed by Lockheed Martin to transport astronauts to and from lunar orbit. With a 5-meter diameter, 3.3-meter-tall habitable crew module, the spacecraft is built to accommodate a crew of 4 astronauts for up to 21 days when undocked and up to 6 months when docked. The module shares similarities with the Apollo Command and Service module, but with a larger diameter and modern technological enhancements. Connected to the crew module is the European Service module, which is an Airbus innovation. It boasts a 4-meter diameter and 4 7-meter-long solar wings. The European Service module is essential to the Orion spacecraft, providing power, propulsion, air, water, and thermal control. To ensure safety, the spacecraft is equipped with a launch abort system. This system rapidly separates the crew module from the launch vehicle in case of an emergency. At 81 minutes after liftoff, the second stage initiated the translunar injection burn before disconnecting from the Orion craft, which carried 10 CubeSat satellites. Orion embarked on a 5-day odyssey at a distant retrograde lunar orbit for 6 days. Exiting this orbit, Orion retraced its path back to Earth, undertaking another lunar flyby. On December 11, 2022, at 12:50 p.m. Eastern Standard Time, Orion's splashdown marked the successful completion of the Artemis 1 mission. This event symbolized the end of a chapter precisely 50 years after Apollo 17's lunar landing. The Artemis program resurrects NASA's lunar aspirations. Artemis 2, scheduled for no earlier than September 2025, plans to send the Block 1 configuration of the Space Launch System and Orion on a 10-day mission into Earth's orbit to perform a flyby of the Moon and return to Earth for the first crewed mission beyond low Earth orbit since Apollo 17 in 1972. Artemis 2 is to be crewed by 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, payload specialist Christina Koch, and mission specialist Jeremy Hansen. The Orion spacecraft will be sent to high Earth orbit with a period of roughly 24 hours. During this time, the crew will perform various checks on the spacecraft's life support systems. Similar to Artemis 1, Orion will separate from the Interim Cryogenic Propulsion Stage and begin its upper stage separation burn, that is a high Earth orbit checkout. When Orion reaches the point at which the Moon is nearest to the Earth, it will fire its main engine to complete the trans-lunar injection maneuver, which will send it on a 4-day outbound trajectory to the Moon. Once in the Moon's orbit, Orion will make the lunar flyby, getting within 6,400 miles to the lunar far side of the Moon, or 10,300 kilometers. After the flyby, Orion will use the Moon's gravity and its auxiliary engines to slingshot the spacecraft on a return trajectory to Earth. Once in Earth's orbit, the crew module will separate from the service module, and the crew will enter the Earth's atmosphere and splash down in the Pacific Ocean. This mission sets the stage for Artemis's upcoming lunar touchdown. NASA's Artemis 3 mission has been rescheduled to September 2026, though the U.S. Government Accountability Office reported that the mission is not likely to occur before 2027. Either way, this mission will be a significant milestone as it will carry the first woman and person of color to the Moon. The spacecraft will consist of SLS Block 1 and Orion, transporting 4 astronauts to the Moon. This will be the final mission using SLS Block 1, the design used for the first 3 missions. Afterward, from Artemis 4 until Artemis 8, missions will use an updated SLS variation. Before the crew launch, SpaceX will launch a storage depot to Earth's orbit. A series of reusable tankers will carry propellant to the storage depot to fuel the human landing system. Designed by SpaceX, the uncrewed Starship human landing system, measuring 50 meters in length and 9 meters in diameter, will then launch to Earth orbit and rendezvous with the storage depot to fill its tanks before executing a trans-lunar injection engine burn and traveling approximately 6 days to a lunar near-rectilinear halo orbit where it will await the Artemis 3 crew. Once Orion and the astronauts make it to lunar orbit, the Orion spacecraft will dock with the Starship human landing system, enabling 2 crew members to transfer. The Starship HLS will then land on the lunar South Pole, where the astronauts will embark on a 6.5-day exploration mission wearing Axiom Space EVA suits. The 2 astronauts will conduct up to 4 spacewalks on the Moon's surface, performing a variety of scientific observations, including surveying geology and retrieving samples of water ice. Before the Artemis 3 landing, some additional equipment will be pre-positioned on the surface, including an unpressurized rover for astronauts to use during their lunar excursions. When their surface expedition is complete, Starship will lift off the surface of the Moon and head back to near-rectilinear halo orbit in Starship to rendezvous with their crewmates in Orion. After docking, the crew will spend up to 5 days in orbit, transferring samples between the vehicles and preparing for the journey back to Earth. When they reach the optimal NRHO departure point with all 4 astronauts back in Orion, they will undock and ignite Orion's engines, slinging the spacecraft past the Moon and allowing it to coast toward Earth. The crew will travel about 24,855 miles, about 40,000 kilometers per hour during re-entry into Earth's atmosphere. Assisted by 11 parachutes, the spacecraft will splash down in the Pacific Ocean, where it and the crew will be retrieved with support from the U.S. Coast Guard and U.S. Navy. While Orion returns to Earth, Starship HLS will be disposed of by sending it into heliocentric orbit. Artemis 4, launching in September 2028, will mark the first crewed entry into space for the Lunar Gateway Station and the second lunar landing of the Artemis program. The mission will use a more robust SLS Block 1B, with a more capable exploration upper stage and a cargo hold to transport other payloads, and launch from Kennedy Space Center's Mobile Launcher 2. The heavier total mass of the SLS Block 1B vehicle requires use of the Mobile Launcher 2 ground support equipment. Developed by Boeing, the exploration upper stage will replace the Interim Cryogenic Propulsion Stage. Powered by 4 Aerojet Rocketdyne RL-10C3 engines and houses liquid oxygen and hydrogen tanks, it will produce a total thrust of 433 kilonewtons and improve the payload capacity to 42 metric tons into translunar injection, surpassing its predecessor's 27-ton capacity. Prior to the Artemis for full launch, the first 2 gateway elements, the power and propulsion element by Maxa Technologies and the habitation and logistics outpost by Northrop Grumman, is scheduled to launch together in November 2024 aboard a SpaceX Falcon Heavy rocket and spend a year spiraling out to the near rectilinear halo orbit around the Moon. The habitation and logistics outpost provides habitation spaces and serves as a connectivity hub, while the power and propulsion element generates solar power, propels the spacecraft, and handles communication. The first science instruments for Gateway will include the Heliophysics Environmental and Radiation Measurement Experiment Suite, Hermes, and the European Radiation Sensors Array, ERSA, that will fly outside Gateway to monitor space weather and the Sun's radiation environment, respectively. The main objective of the Artemis 4 mission is the further assembly of the Lunar Gateway Station, which represents the cornerstone of sustained human presence on the Moon. The ambitious space station will orbit the Moon in a near rectilinear halo orbit and will be the epicenter for lunar surface operations. The Orion Spacecraft, with the Exploration Upper Stage and International Habitation Module, will rendezvous with Gateway and perform a docking procedure, thereby attaching the module to Gateway. Once complete, 2 astronauts will transfer to the Starship HLS for lunar exploration before joining the other 2 crew members aboard the Orion spacecraft for the return journey to Earth. Artemis 5, scheduled for September 2029, will follow Artemis 4's launch procedure. The mission will again launch 4 astronauts on the Space Launch System Block 1B rocket along with Orion to bring 2 new modules to Gateway before landing a 3rd time on the Moon's surface. The 2 modules will be the Canadian-built Canadarm3 and the ESA-built Esprit module, which stands for European System, providing refueling, infrastructure, and telecommunications. Canadarm3 is a pair of remote robotic manipulator arms, one large and one small, designed to maintain, repair, and inspect the Gateway, capture visiting vehicles, relocate Gateway modules, and help astronauts during spacewalks. Meanwhile, the Spirit module will provide refueling capacity, additional communications equipment, a habitation area, and increased storage. It will have a launch mass of approximately 10,000 kilograms or 22,000 pounds, a length of 6.4 meters or 21 feet, and a diameter of 4.6 meter or 15 feet. The mission will use the Blue Moon lander, designed by Blue Origin for lunar touchdown, and host NASA's Lunar Terrain Vehicle for surface traversals. After the mission is complete, the astronauts will rendezvous with the Orion spacecraft for the return journey to Earth. The Artemis program aims to establish a permanent lunar outpost with rotating crews. The program envisions a series of expeditions beyond these missions. Artemis 6, scheduled to launch using the SLS Block 1B on September 2030, will deliver the crew and science airlock module for Gateway and feature another lunar landing. At this point, Artemis 1 through 6 are the only planned missions of the program. The following missions, 7 through 11, have been proposed with specific goals in mind. Next mission, Artemis 7, is scheduled to launch September 2031 and will deliver 4 astronauts and the Habitability Mobility Platform, or Lunar Cruiser, to a surface lunar outpost known as the Foundation Habitat. Developed by JAXA and Toyota, the lunar cruiser will be a fuel cell electric vehicle, enabling astronauts to take trips across the moon, lasting up to 45 days. Artemis 8, scheduled for a 2032 launch, will deliver the foundational lunar surface habitat along with other lunar surface logistics equipment. The habitat would serve as permanent base camp for future lunar missions, allowing for longer duration stays. Artemis 9 will feature an upgraded SLS Block 2 launcher in 2033 and will deliver further lunar surface logistics to the Moon's surface, while Artemis 10 in 2034 and Artemis 11 in 2035 will deliver expanded logistical support and incorporate extended lunar stays of up to 180 and 365 days, respectively. Ultimately, the program aims to establish a lunar village, utilizing lunar resources to foster a burgeoning lunar economy and beckoning humanity towards a cosmic frontier. The Artemis mission is a monumental achievement in space exploration. While the mission to the Moon is an incredible feat, its significance extends beyond the lunar surface. Artemis represents the initial step towards sending humans deeper into our solar system and eventually to Mars. The Moon serves as an ideal testing ground for the development of life-saving technologies that will aid us in our journey to the Red Planet. Establishing a base on Mars will unlock a vast array of possibilities for exploration beyond our wildest dreams. We could be the generation that explores far-off planets and becomes a spacefaring civilization that breaks down barriers and alters our place in the cosmos. We hope you enjoyed our video and share our enthusiasm for the voyage ahead. To remain up to date on all the latest developments, be sure to subscribe to our channel for more awe-inspiring content. Thank you for joining us, and together, let's explore beyond the stars. See you soon.